Hello everyone. Hopefully you can hear me better. I tried to fix my audio from last week. But anyway, um, welcome to the second week for the Chemistry Tutoring 221. If you weren't here last week, I'll be helping you guys out with weekly material that maybe you want to be covered more in your classes. So let's get started. We're going to be going over atomic structure and how you identify how much a charge is and if what goes with what compounds and if those are ionic bonding or covalent bonding and nomenclature and whatnot. So we're going to be going over at the end of chapter 2 questions in your textbook. And let's get started on the first one. So if you can see my screen. So first, let's get started off with identifying different structures on the periodic table and how we can identify them. So for alkali metals specifically, we have, I will highlight in green so it's easier to see. Right here. So alkali metals on the periodic table will always be right here. That is where they exist, other than hydrogen. And for alkaline earth metals, it just goes in a row. It's pretty standard for that. And so that'll look like. Let's go with this. So they will be identified here. And then for the nitrogen family, it'll be under nitrogen. Right here, and then for oxygen it'll be right next to it under oxygen, and then for halogens it'll be right here. I know I'm not the highlighting isn't the same color, but it's all right. So that's where all of these are located, and for the transition metals that includes all of the metals in between right here. So that's where everything is located. So that's really good to know for different charges because the alkali metals will have +1 charges, so they'll lose a electron to make an ionic bond with whatever it's going to be bonding with. Let's just say it'll be with a column of fluorine. So that's good to know the charges that each of the different metals and non-metals have, and in all of those different families. Okay, so now that we kind of know where everything is, let's get to our first question. So for 11A, we're going to be going over ion identification. So we have a ion with a 1+ charge, atomic number of 55, and a mass number of 133. So what that looks like is when we're writing out the structure of what an ion looks like, we want to put the mass number in the top left. It's 133, and the atomic number is 55 on the bottom left. And if it has a charge at all, that goes on the bottom or top right. So 1+. And I'm going to be using the periodic table to see what kind of atom this is. So we have a atomic number of 55. So when we're looking at the periodic table here, we can see that this one right here, cesium, I believe I pronounced it correctly. That's the one that we're looking at. It has an atomic number of 133. Rounding, it's 132.905, but that's just the average. And it has an atomic number of 55 and a +1 charge. So we're working with this atom here. So in the very center, we're going to write down cesium. So that's Cs. Okay, next on 11B. So we have 54 electrons, 53 protons, and as well as 74 neutrons. So to figure out the mass number, it's always going to be the neutrons plus the protons. So let me write that down. That is protons plus neutrons. And since neutrons have a 0 charge, I'm just going to have the the not symbol to symbolize that. So since we have 53 in this example and 74 neutrons, that will be a total of 127. So just as similarly as we did in 11A, at the very top left, we're going to put the atomic mass number, so 127, and we have 53 protons, so that's going to be our atomic number. And as far as the charge, since we have 53 protons and 54 electrons, there is an abundance of an extra electron, so that's going to have a 1 minus here at the top right. So that's the charge that we have. And so looking at our periodic table, we're going to find the atomic number, which is 53. And so look back here, and that seems to be iodine, and that seems correct with charge that it has, because it has, if you can see, it's really small, but it can have a +5 or a -1, and most commonly it's going to have a -1 charge because of how it ionically bonds to other atoms. So that is iodine, so we will put the I symbol right in the center. So that's what that looks like. Okay, so 11C, let's get to it. It's an atomic number of 15, a mass number of 31, and a 3 minus charge. So since it has a mass number of 31, it will have 31 at the top left, and since it has an atomic number of 15 at the bottom left, it will have 15 here. And since it has a 3 minus charge, that goes at the top right. And we can look at our periodic table again. And so let's look at something with an atomic number of 15. So that will be phosphorus. So phosphorus is the one that we're working with here. So the P goes in the center, the symbol. So 11D, so we have 24 electrons, 30 neutrons, a 3 plus charge. So since it didn't give a mass number or an atomic number, we have to identify it as we have done before. So 24 electrons, let's keep that in mind for the charge. That's why the electron is more significant. And then for the mass number, again, that will be the neutrons plus the protons. And so since this one has a 3 plus charge, that means that it has an abundance of more protons. So because of that, it'll have 27 protons because it's a 3 plus charge. So if there are 24, like 24 is it's negative. We have a negative 24 because that's the electrons are negative. And if our end goal has an overall +3 or just +3, to identify how many protons we have, we just add 24 on both sides, and so that's 27. So we have 27 protons here. So that will be our atomic number. So that was on the bottom left. And our mass number, since we have 27 protons and 30 neutrons, 27 plus 30 equals 57. So we have an atomic mass number of 57, so that goes on the top left. And since we have 3 plus charge, that goes on the top right. And we can identify it looking back at our periodic table. So let's look at the periodic table with the atomic number of 27. So going back here, 27 should be cobalt. So that's what cobalt is. And we have a +3 charge, and that's still fun. I know that you probably can't see that too well, but at the very top right, it's +3 or +2. So that seems to go with where answer is. So cobalt is the answer for them. Okay, so now let's look into 19A. We're going to be going over identifying how many protons, how many neutrons, and how many electrons are in each of these examples. So for 19A, we have lithium, and the mass number is 7 here, and the atomic number is 3. So we know right off the bat that the atomic number is the amount of protons. So we have protons. And all of these don't have charge on them, so we can say that the protons and electrons have an equal amount of both because neutral. So the positive and the negatives cancel each other out. So 3 protons and 3 electrons for this one. And since the mass number is 7, and we have the mass number is neutrons and protons, 7 minus 3 equals 4. And so we have 4 neutrons. And so that's how we figure that out, similar to what we were doing before. So we have this atom here. I don't know what this one is, but it's Te. And we have 52 protons because the atomic number is 52. And since it's neutral, just as before, it also has 52 electrons. And so 125 minus 52, to figure out how many neutrons it has, is 73. So we have 73 neutrons. Okay, so for gold here, we have 47 as the atomic number. So we're going to have 47 protons and 47 electrons, as well as, let's figure out the neutrons. So 109 minus 47 equals, that is, we're going to see, that is 62. So we have 62 neutrons. Okay, and so for nitrogen, or I believe that's what this is, yes, we have 7 protons, 7 electrons, and 15 minus 7 equals 8. So we have 8 neutrons here. Okay, in phosphorus, we have 31 as the mass number, so 31 minus 15, we could figure out the neutrons as the one before, so that would be 16 neutrons, 15 protons, and 15 electrons. So hopefully that makes a little bit more sense on how to identify how much is of what. So that's number 19. So let's go 24. So 24 is a more heavy problem. It has to do with figuring out the atomic mass of naturally occurring versus the commercial source. So for these, what we have to do is we have to use the equation, which is, I'll write in red. So the average atomic mass is equal to the sum of the abundance, so that's the percent of which it occurs, times the isotopic mass. And so that's the AMUs that we see right here. And yeah, that's what that is. So to figure out the naturally occurring, we have 7.5% of the lithium 6 isotope, as well as 92.5% of the lithium 7 isotope. And so to figure out what the atomic mass is of that, we will use the similar equation that we just talked about. And so what that looks like is we have the abundance, so that's 0.075, that's percent, and this is the mass that we're working with here, so that's the amount that it's occurring. So 7.5% of this isotope has mass, 6.01512, and we're going to add it to the rest of what is naturally occurring. So that's 0.925, it's the same as the percentage, times 7.01600, and that's right there, that's how much this weighs, and that's how much it occurs. So then we multiply and add those two. And so what it gives us, I already solved this out, so it's quicker to write down. The first term is 0.451134 plus 6.4898 And so because we're working with 7.5%, so we're working last week we talked about significant figures. So what that'll have is 2 sig figs in our final term here. And for 92.5%, that's 3 significant figures. So for this multiplication right here, we want 3. So when we're adding these two terms together, we can see the ends at the 100th place, both of these. So our final answer when we add these both together, it'll be 6.9409, but then we can round it to the 100th place, keep in check for the significant figures. And that's the units of AMU. So that's the average atomic mass. And so that's the naturally occurring. Let's compare that with the commercial source. And we're given in the problem that it's 0.75% of the 6 isotope and then 96.25% of the 7 isotope. So let's write that down. So we have 0.0375 times 6 added to 0.9625 times 7. And so multiplying and adding these together, it'll give us 0.225 plus 6.7375. And so for this term here, when we're working with 3.75%, that is 3 significant figures. And for 96.25%, that is 4 significant figures. So keeping that in mind, we're multiplying these two terms. We're going to keep all of these 3 digits here, as well as all 4 of these digits. And so we can see again that they end right at the thousandths place. So then when we're adding these two together, we're going to keep that in mind. And so since this is the number that we have when we add those two together, we round to the thousandths place. So 6.926 AMU. So similar to the last one, we have an answer of 6.94 versus 6.9. Oh, sorry, that should be 9625. Sorry about that. So that should be right there. So looking at those two values, it just has one more significant base that we're looking at. So they're almost exactly the same, which is a sign that we're doing this math correctly, and these isotopes are very similar. Okay, so let's move on to 48. So we're going to be looking at if these are going to be ionic or covalent bonds, and if it is an ionic bond, then we could see what these ions look like in its separation from the compound. So we have the first one as KClO4. So in identifying this K right here is going to be a metal, and that is, if we're looking back at our periodic table, that is potassium, and that's an alkali metal, and it has a +1 charge. And the ClO4, let me just go all back here, that is going to be perchlorate, and that's one of the ions that you need to know for your class. So we know this is a metal, and this is a nonmetal. All of these are nonmetals, the chlorine and oxygen. And so because of that, this is going to be an ionic bond because it's a metal and a nonmetal. And so since potassium has a +1 charge, it has a plus here, and perchlorate has a -1 charge. And so those are what the ions look like. And just to cover that again, perchlorate, and this is potassium. Okay, now moving on to B. So we have this thing here and this thing here, and the thing on the right, if you've noticed it before, this is what acetate is, and acetate is a non-metal, and that on the left is magnesium, and magnesium is a metal. So again, we have a ionic bond here, And so since this is ionic, and also last one is ionic, we have a charge of magnesium, and that has, I believe, H plus charge. And when you go back to the periodic table, it's a alkaline metal, and so those have +2 charges because they lose 2. So the magnesium has a 2 plus, and the acetate, normally it has a minus charge, and so since there are 2 of them, that's how many you need to balance it out. So you have 2 of the acetate, and so that's what that looks like right there, because there's 2 of those ions. And we write the 2 in front of it as a singular when we're talking about the ion, but when it's with the compound, we put the 2 as subscript. And that's how we write those symbols out. So let's move on to C. And this is hydrogen here. And this is sulfur. And these 2 are both nonmetals. And so since those are nonmetals, this is covalent. And so since hydrogen has a +1, it shares 1, and sulfur has a 2 minus, it's going to be sharing 2 electrons. And it does not give away or take any electrons, or else that would be ionic. So this is a covalent bond, and it shares 2 electrons. If we don't have any questions, I'm going to move on to formulas of compounds. So this is 49A that we're going to be working with. So the first one that I have here is calcium. The second one is sulfur. And so calcium is a metal, and it's also an alkaline metal, which goes together with the 2 plus column. And the sulfur and the nonmetal, and it has 2 minus. And so since these 2 charges cancel each other out, that is why we directly write them like this. And the metal always goes first, the positively charged ion goes first, and then the negatively charged ion goes second. So we have calcium sulfide right there. Okay, so for 49B, we have H4 plus and CO4 2 minus. And so NH4 plus is ammonium. So we have ammonium here. And then the SO4 2 minus is sulfate. And these are also a couple of ions that you should be starting to memorize and get to know a little bit more. They'll come up a lot, so you'll be able to really understand them and recognize them much quicker as time goes on. So since we have a +1 charge and a 2 minus here, we need 2 ammoniums to balance out the sulfate. So what that'll look like is NH4. We'll have 2 of those. And then the SO4 goes on the right. So that's how that compound would look. And so let's move on to 49C. So we have an aluminum here and a bromine. And so aluminum is also a metal. It's a transition metal. And we have bromine, which is, I believe, let's look back at our bromine. Yeah, it's part of the fluorine family. Yeah. So let's see what that would look like as the formula. And so since this has 3 plus and this is a minus, we need 3 of the bromines to neutralize out the aluminum, so we can have equal amount of taking and giving. So we have aluminum Br3, and so that's what that would look like. So now let's move on to question 53, and so we're going to be writing down what these will look like as the actual compound itself, as well as the ions. So the first one we have as for 53A is rubidium bromide. So on the periodic table, I won't go back, but the symbol is Rb, and it has a charge of +1, so it's alkaline metal. And bromide has a -1 charge, and so since these two neutral each other out, just have a ratio of 1 to 1, they will have R, B, Br as the formula. So for 53, we have magnesium selenide. And so magnesium has a symbol of Mg. It has a 2 plus, and selenide has a 2 minus. And also it has a 1-to-1 ratio because they neutral each other out with the 2 plus and the 2 minus. So then that'll look like MgSe. So let's move on to 53C. We have sodium oxide. And so since sodium has a symbol of Na and it has a plus charge, and oxygen has a charge 2 minus, we don't have a 1-to-1 ratio here, so we'll need to have 2 sodiums to neutralize the oxygen. And so that looks like Na2O. So that's what sodium oxide looks like. And hopefully it'll get a bit easier with understanding all these ides and recognizing that oh, you know, this is an ionic bond, and that's how these look like with how we neutralize them out and how they can give electrons and what that looks like for different ratios. So we're going to be doing more of that. So let's go to 54A, and we have lithium carbonate. So lithium has a charge of 1 plus, and carbonate has a charge of 2 minus. And so that's also one of the ions that you should be getting to know more familiarly. So because this has a 1 plus and this is a 2 minus, we need 2 of the lithiums to neutralize out carbonate. So this will be Li2 CO3. So next we have sodium chlorate, and we just talked about perchlorate just a couple minutes ago. And so we're going to write down what these ions look like. So for sodium, we have Na plus. Perchlorate is ClO4, and that is a minus charge. And because it has a 1-to-1 ratio for neutralizing out the charges, we just write the metal first, which is the alkali metal, sodium, and then perchlorate. So it looks like that. So for C, we're going to be going over barium hydroxide, and hydroxide is an OH. This is also an ion that you should be getting more familiar with, and barium is Ba2 plus. And so because this ratio is a 2-to-1, we need 2 of the hydroxides to neutralize that barium. We have BaOH, and because this hydroxide is, we want to say that, you know, we need 2 hydroxide. We don't just put the 2 next to the hydrogen. We want to put parentheses around it to encapsulate this is the whole thing that we need 2 of. Because if we not do that, this would look a lot differently. This would be 1 oxygen and 2 hydrogen, which is not the same as hydroxide. So that's what that looks like. So now let's go over naming compounds. So naming compounds get a little bit more tricky with different transition metals because you need to keep track of their charges. So you always need to put down like the number next to the metal to signify what charge it has. So in this one, I'll give an example of that. So we have Cr2O3, and so this chromium right here. But chromium, it can have different charges. So it can have like a 6 plus, or it can have 3 plus charge. And so because of that, we need to look at the oxygen. And because this is neutral, we have to kind of do some puzzling and try to figure out what was left over to neutralize it. So oxygen has a 2 minus. And because we have 3 of these, that's a 6 minus. And we have to cancel out. And we have 2 of those chromiums here. And so because of that, we have plus 2 of Cr. And this all equals a neutral amount of 0. So if we just do some simple algebra, add 6 to both sides. And so what that looks like is 2 Crs, 2 chromiums, equals 6 divided by 2 on both sides. And so this will have a positive free charge. And so because of that, I'll move everything down. so because of that, we know that this is a 3 plus charge. So for the naming of the compound, we're going to put chromium. And you don't change the first one. And like I said before, since it has a 3 plus charge, we put a 3 symbol next to it to signify this is a 3 plus. And because it's the ionic bond, we change the second name to an ide, so we have chromium oxide here. So now let's move on to 57B, and so we have an Fe and Cl2, and this is also an ionic bond because the iron is metal and the chlorine 2 here is a nonmetal, and so these are going to be taking and giving electrons instead of sharing them. So this is an ionic bond, so that changes with naming of things. So we first have iron here. The Cl2 here is chloride, but we also need to do the same thing as we did with the first one. We have to signify the amount of charge and then put the symbol of the number right next to it to identify, hey, this is a 2 plus charge, not a 3 plus. So because this is neutral again, and we have 2 chlorines, and this has a minus charge of the chlorine, and we have 1 iron, and this equals 0, we can do also what we did last time, put them over to the left of the equation. So we have, actually I'll do 2 or minus 2, add them to the right, the plus 2, so now we have iron as a 2 plus charge, and so because of that, this iron will have a 2 symbol here. So that's what that looks like. Move everything down again. And for C, similar as before, I'll zoom out so you can see this a little bit better. This is also chromium, and that's also oxygen. This is a case of figuring out what chromium has as a different positive charge because it can have different positive charges. So we have 3 oxygens. So similar as before, this will have a minus 2, and so we have 3 of them. That equals minus 6. And so since we have minus 6 plus 1 chromium, this whole thing will be neutral, so it all equals a 0 charge. And so if we add 6 to both sides, the chromium would have a plus 6 charge. It's a lot bigger than before, as in terms of positive charge. So this will have the name of chromium 6, and that is IV, and is oxide. Just as for when we did the ide to ionic bonding of the second name. Okay, now let's go over 59A. So we're going to be writing down the formulas this time. So we have potassium phosphate, and so what that looks like is potassium is a metal. It's an alkali metal. So we have K here as a symbol, and we have plus 1 because that's the charge it has. And then for phosphate, we have the ion that looks like this, PO4, and it has a charge of 3 minus. And so because there is a plus 1 and a 3 minus, we need to figure out how many plus 1s will neutralize the 3 minus. And so what that will look like is K3, PO4, because we need 3 of the potassiums to neutralize at the phosphate. So for 59B, similarly with the 2 next to the metal, we know right off the bat that this copper is going to have a 2 plus, and so that's really good for figuring out how to write the formula. So that's what that ion looks like. And so for sulfate, we have SO4, 2 minus, and so because it has an equal ratio, 2 plus and a 2 minus, adding those 2 will neutralize them, so we don't need to change any coefficients. So we directly have 1 copper and 1 sulfate each. So let's move on to calcium chloride here, and we have calcium like this and chloride, and this has 2 plus, just as written, and the chlorine, which will be the chloride, will have a minus charge. And so since we have a 2-to-1 ratio here, we need 2 of the chlorines to make the chloride to neutralize out the calcium. So we have CaCl2 because of it. So that is all that I have for everyone today. Hopefully this is better understanding of how to write down the formulas for different ionic covalent bonds, how to figure out how many neutrons, electrons, and protons that an atom has, and how to write down symbols. And getting familiar with the different ions takes time because there's a lot of them to memorize, but as you go through the chemistry series or beyond, you'll to familiarize yourself with them. So does anyone have any questions? I'm happy to go over anything else, but if not, we can end it today, and this is also going to be uploaded to YouTube just in case you want to listen to anything back or go over any previous problems I have.